All right, welcome to our first video on factoring quadratics, the second video of our overall series on factoring. So this is the one for x squared plus bx plus c, in other words, where the leading coefficient is 1. So if you have something that just starts with variable squared, you're in the right place. We're going to start this video and this example by looking at what we ended the last video with. We can turn this into a factor by grouping and greatest common factor problem. It's actually quite easy to do. So the first thing to remember is if we have a quadratic, it has a standard form of ax squared, bx, and c. When standard form, it shows everything being positive, but of course you can make any of the three terms negative if you want or if that's what you're given. In this case, a is 1. The first coefficient for x squared is 1. So you're going to take that coefficient and you're going to multiply the a times c. 1 times 64 is 64. You're going to find two factors of that number that add or subtract to b. b is negative 16. Don't worry about the sign right now, just worry about the 16. So my factors are 1 and 64, 2 and 32, 3 and, wait, not 3, 4 and 16, not 5, not 6, not 7, but 8 and 8. 8 and 8 make 16, that's the pair I need. Rewrite bx as an add or subtract problem. Okay, so we're going to take our x squared, and now if I want a negative 16 out of 8 and 8, they would both need to be negative, right? Negative 8 plus negative 8 is negative 16. Negative 8x, negative 8x, plus 64. And from here, I'm going to factor by grouping the same as we did in the last video by taking the first two terms and the second two terms. X squared minus 8, they both share x, but nothing else. Divide it out. X squared divided by x is x, minus x and x cancel, and I'm left with the negative 8. Check. I can get back to this. X times x is x squared. X times 8 is 8x. The minus is between them. I have done this correctly so far. For 8x and 64, I'm going to take out the negative because I want to make that first term positive. They both share an 8, but nothing else. Negative 8. Negative 8 divided by negative 8 is positive 1. The x stays, plus 64 divided by negative 8 is negative 8. And you can just turn that into minus 8 if you like. So then after that, I can see that the two parentheses match. X minus 8, x minus 8. So I'm done. I have something I can write as a FOIL. So I'm going to take my two GCFs just like I did last time, x and negative 8. And then I'm going to take x and negative 8 again. Now, there is another way to write this. If you come across something that's identical, you can call it x minus 8, and we would say that is x minus 8 quantity squared. Okay? Either one of these two formats is correct. Now, obviously, if they are different, you couldn't do that second part. You would just say like x plus 1 times x minus 2, for example. Right? Now, there is a little bit of a shortcut here that we're going to discuss in the next slide. The shortcut here is quite simply the fact that, well, if I have something like this, a is 1. So a times c is always just going to be this number. So I could find two factors of c, 54, that add or subtract to b. Now I want to be very clear. This only works in this case because a is 1. The first coefficient is 1. If you had something where the first coefficient was not 1, this shortcut does not work. The factors of 54 are 1 and 54, 2 and 27, 3 and 18, not 4, not 5, but 6 and 9. And to get 15, I have 6 and 9. So I'm just going to say, well, if you look back at the last problem, I chose 8 and 8. So in this problem, I can actually just go straight from the problem to the answer. So I'm going to have 8 and 8. I know that, well, not 8 and 8, wow, 6 and 9. Recopying the other problem. So if I have that, I just need to figure out how to make that 15 negative. Well, the 15 is negative. Well, that would be negative 9 and negative 6. Because 9 plus 6 is 15. If they're both negative, my answer is negative. And again, this shortcut works. It's fine to use it. But only if we have a situation where the leading coefficient, that number attached to x squared, is 1. All right, I'd like you to go ahead and practice this one. And the answer here is m plus 4 times m plus 8. Again, I use the shortcut because I know the leading coefficient is 1. So I have 32 factors of c that will add or subtract to b. So 8 plus 4 is 12. Everything's positive, so both 4 and 8 are positive, and that is my answer. Again, how do you check if you use the shortcut? Well, we'll actually talk about that in the next problem. So on 5, and by the way, notice the standard form is always x. You can use whatever variable you want. I'll be honest, I really don't like when they use a, b, or c as the variables because that kind of confuses the coefficients in standard form a, b, c with the variables in the problem. That's more of a personal preference, I guess. I'm going to use the shortcut again. 50, 1 and 50, 2 and 25. Not 3, not 4, 5 and 10. Okay. 5 and 10 is the pair. And by the way, when I do this in class, students will always ask me, well, what happens if I get to the pair that I need first? Do I have to list the rest? No. As you're listing, if you come out, or I should say when you come out with the one that you need, you get to stop listing them. Okay, so shortcut, I just take my 5 and my 10. I know that everything is positive, so 5 and 10 should both be positive. 5 plus 10 is 15. Now, like I said, these are a little bit easier to check because you're not doing a whole lot of steps, especially when using the shortcut. So, just, be aware of that. But if you want to check, you can FOIL. So I would do first, k times k is k squared. I would go ahead then and do outer. K times 10 is 10k. I would do inner. 5 times k is 5k. And then I would do last. 5 times 10 is 50. Putting it all together, I would get, oops, I'm going to write the x by mistake, k squared. Like terms are 5 and 10 plus 15k because they're both positive, plus 50. That is what I had to begin with. I have factored correctly. So if you're using the shortcut, there is not so much of a check at each step like I showed you with factor by grouping to make sure that you're doing it correctly. It has to be kind of at the end. But again, you kind of go right from the problem to the answer. So, that is a little bit of a trade-off in terms of the amount of work. All right, v squared minus 4. This one looks a little weird, right? Because we don't have the middle term. We don't have a trinomial. We have a binomial. Okay, so with this one, you can have a situation where the middle term is missing. You can't do this if the last term is missing. If there's no c, then it's factor by GCF. So since the middle term bv is missing, it is 0. bv I just used because the variable in this problem is v. So find two factors of c that add or subtract to 0. I will see students quite often write this just to remind themselves they're looking factors of 4 that will get 0. The factors of 4 are 1 and 4, 2 and 2. I know that 2 minus 2 is 0. So I would say that V, and then I will have my 2's. And the way that I get that is 1 positive 2 and 1 negative 2. You'll remember, hopefully, from before that this is the difference of squares. So if you see difference of squares, you should remember that to multiply for difference of squares, the parentheses are identical except the number in one is positive and the number in the other is negative. So if you're factoring, that's the format you should find for your answer. You can do it this way as well. Okay. Notice that 2 is also the square root of 4, and v squared is also, or v is also the square root of v squared. So with that, that's the way the textbooks a lot of times will show you, kind of using a more formula approach. You can use this technique as well. It is a quadratic expression and can be factored like any other quadratic expression. All right, let's do this one. X squared minus 7x plus 7. Factors of 7 are 1 and 7. There is no way to get 7, positive or negative, out of 1 and 7. The only thing I can make there is 6, negative 6, 8, or negative 8. This one is prime. There are no factors of C that will add or subtract to B. So nothing more I can do here. All right. So that's the end of our video on factoring x squared plus bx plus c. So just to review the technique, I'll go with the shortcut. You find two factors of c that will add or subtract to b. You pick those two, you put them in parentheses, and then you decide on which is positive or negative, one, the other, or both, by looking at the middle term. So just to recap, in the problem here, we chose both positive numbers because we have positive 15, so positive 5 and positive 10 make 15. In this one, we chose one positive and one negative because 2 minus 2 is 0. And then in this one, we chose 2 negative because negative 6 minus 9 is negative 15. Right? Be sure to watch our last video on factoring ax squared plus bx plus c when a is not 1.